Hi, I'm Michele Bullock. I'm a licensed massage therapist in Washington State, and I'd love to bring you massage and bodywork licensing exam resources. Now that's through videos here on YouTube and also on my website. You will find lots of courses and downloadable stuff. So, and that's also the sponsor of this video is my website. So in the description below, you'll find links to all that stuff. In this video, let's see what we're going to be talking about here. Oh, I need to switch over to the other one. In this video, we're going to be talking about chemistry basics for body workers. We're going to be talking about why chemistry is important for massage therapists and body workers. We're going to be talking about the building blocks of cells. Chemicals are the building blocks of the cells. Atomic elements of the body, organic versus inorganic compounds, organic compounds in the body, and how they work. So we're lipids, proteins, carbohydrates, and nucleic acids. And then at the very end, we're going to be going through some MBLEx style questions regarding the information that was in the presentation. So if that is stuff that you need to know, make sure and hang in there all the way to the end. Now, I wanted to make sure that you all understood that there is much more to chemistry than what I'm presenting here today. There are thousands of videos on YouTube that you can check out. But you don't need to know all that stuff in order to pass the MBLEx. What I'm presenting here is exactly what you need to know in order to pass the MBLEx, about the information from this applied anatomy and physiology textbook that a lot of massage therapy programs use. And so therefore it is information that the MBLEx is expecting you to know. So it's just a very, very brief overview of the chemistry that you need to know. Okay, so it's not a big deal. And let's see, what else did I want to talk about? Yeah, I'll remember later. Okay, and without any further ado, let's just go ahead and get into the presentation and make sure and subscribe. Make sure, oh, that's what I wanted to say. Your downloadable slideshow is in the description below. So I have a PDF printout of all the slides in this presentation, so you can reference it later on and also look at those practice questions so you know what to expect regarding questions that you might get regarding chemistry on the MBLEx. Okay, we'll go ahead and get started, and I'll see you over there.
What is chemistry? It's the study of how atoms and molecules interact to form the structures of the body and drive the chemical reactions essential for life and health. For example, the way that oxygen binds to hemoglobin in red blood cells to transport it throughout the body is a chemical process that directly supports respiration and energy production. Plus, respiration and energy production are chemical processes. Chemistry is the basis of that triangle I showed you in the last video, where we looked at the components of an organism, right? Chemistry, the atom, that's my stomach. The atom is the basis of everything, not only for carbon life forms like ourselves, for the tree, for the cat. It's also, chemistry is the walls of the building that you're in. It's the ground that you walk on. It's everything. It's all atoms. Why is it important for licensed massage therapists? It helps us to understand medications and interactions. It helps us to understand energy and muscle function. And it helps us to understand inflammation and healing. So, the building blocks of life. Chemistry and chemical reactions are the building blocks of life because they form the basis of every structure and function in the body. Atoms combine into molecules like proteins, fats, carbohydrates, nucleic acids. And these molecules interact through countless chemical reactions to provide energy, build tissue, regulate processes, and maintain balance so that life can exist and thrive. Okay, so atoms are also known as elements. They're the primary foundation, the smallest unit, and they have an electrical charge to help them stick to other atoms. Now they're made of proteins and neutrons in the center, right there in the middle. And then they have these electrons floating around on the outside. Now, ideally, that's not ideal, actually. Never mind the ideally part. When they are stable, when an atom is stable, it has an equal amount of energy between the protons and neutrons, which are positive, and the electrons, which are negative, which keeps everything in its place so it doesn't need to go anywhere else, right? But if things become imbalanced between the two, either there's not enough electrons and so there's a more of a positive charge coming off of it, or if there's too many electrons and there's a negative charge coming off of it, they end up sticking to other atoms because the negatively charged atoms are very generous and the positively charged atoms are needy, and so they stick together to share electrons. Okay, so when they're stable, no chemical processes happen, and when they're charged up, that's when stuff happens. All right, so just real quick, this isn't something that was explained to be needed to know for the MBLEx, but I just want, for those of you who have not taken chemistry of any sort, just to let you know, like hydrogen here, it's the smallest atom. So it has only one proton and neutron, and it has one electron floating around it. So it's the smallest and the lightest. And as you go through the periodic table, the atoms are getting heavier and heavier because they have more neutrons and protons, and then electrons going around the outside because it has to be as close to being balanced as possible. So compared to hydrogen, copper or zinc is going to be pretty heavy because they have a lot more. And like, so you go 1 for 1 electron on hydrogen, 1 electron on helium, 2 electrons on helium, 3 electrons on lithium, and then so on and so forth. Carbon is going to have 6. So 1, 2, 3, 4, 5, 6 carbon on carbon, 7 on nitrogen, 8 on oxygen. Okay? That's how it goes. Whoop. Okay, so how the atoms go together, multiple atoms binding together can be a molecule, they can be the same atom, or they can be different atoms. It's just a blanket term for multiple atoms binding together as a molecule. A compound is when different atoms bind together. So if you got O2, which is oxygen, that would be a molecule. It would be a compound if it's oxygen with 2 hydrogens. That's water. Water is a compound. Table salt is a compound. And then, so these are inorganic compounds. And then this is an organic compound because it doesn't have anything else except carbon, hydrogen, oxygen, and that is sugar. And like in this diagram, each of these little bends in the curve is a carbon. So that would be 1, 2, 3, 4, 5, 6 carbons. All right. Okay, so primary elements in your body, life forms, are hydrogen, carbon, oxygen, and nitrogen. And this is a diagram of how the electrons are floating around each of these neutrons. So hydrogen, like I said, 1 electron. Carbon has 6 electrons. Nitrogen has 7. Oxygen has 8. These 3 are right next to each other, aren't they? So they're all pretty much the same size. And then hydrogen is the one that's just floating around, wanting to be friends with everybody. Secondary atoms in our body, necessary for chemical processes, for energy creation, are these other ones: phosphorus, sodium, calcium, potassium, chlorine, magnesium, iron, and sulfur. And these are the different electron diagrams of each of these atoms. Okay, organic and inorganic compounds. Organic compounds are molecules which are mostly made of carbon and hydrogen, often with oxygen, nitrogen, or other elements, and they form the chemical basis of all living organisms, including carbohydrates, lipids, proteins, and nucleic acids. Inorganic compounds do not contain carbon, okay, and they include essential molecules like water, salts, acids, and bases, and they support life by regulating pH, fluid balance, and cellular function. Okay, I'm going to take a drink of water. Water. It's in the human body, it's the medium for most, a little bit of noise here. It's the medium for most chemical exchanges, and it's the primary component of all body fluids. Okay, so there's water with all these ions sticking around it: sodium, magnesium, calcium, potassium. Inorganic salts break apart in water, and they release charged atoms called ions. So these ions are sticking to that water, right? Electrolytes are an example of inorganic salt in action. Okay, so the charges that come off of these ions are the reason that they're called electrolytes, because they are electrically charged to, like, they make energy happen between them when they stick or break apart. Okay, so acids and bases. So it's all about how many hydrogen ions or hydroxide ions are hanging out in these compounds. Okay, so lemon juice would be like in here, vinegar would be over here, and then battery acid would be way over here, and 0 to 2, right? Don't drink battery acid, it's bad for you. Okay, and then for bases, you've got soap, bleach, oven cleaner. Don't drink any of that either. Those are over here in more alkaline bases, right? And then neutral in the middle is where our chemical processes are as humans. 7.35 to 7.45 is right in the middle between 7 and 8 for human blood. That's where we want our chemistry to be. Organic compounds, that's carbohydrates, lipids, proteins, and nucleic acids. So right here we have a carbohydrate. That's 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5, and 6 carbons. Glucose, carbohydrate, that's what that is. Same as sugar that I showed you in that chain before. So they're a combination of carbons with hydrogens and oxygens. That's where the body's energy comes from. They break apart and create energy for us. Glucose is the most important. Okay. Lipids. Those are carbohydrates, but they're same as carbohydrates, but they're in kind of different combinations, and they create adipose, which is like fat. They help with hormone production, and they're the building blocks of our cellular structure. So, for example, lipids create our cell membrane. Okay. Proteins. So they are carbon, oxygen, hydrogen, but they also have nitrogen in them. That's what makes them a protein. Okay. Longer chains of molecules, of protein molecules, are called amino acids, and there are many, many, many different kinds of amino acids, and those combine into chains of different combinations to create the proteins that our body is made of and uses, especially important for muscle cells. And then we have nucleic acid, which is DNA and RNA. DNA is deoxyribonucleic acid, and RNA is ribonucleic acid. It's the blueprint for all cellular processes. And you don't need to know what those are made out of, except that they're carbon, like carbon, oxygen, hydrogen, and then they have some other stuff, some other trace minerals. So let's do some MBLEx style questions for what we just learned. Which of the following elements make up the majority of the human body and serve as the primary building blocks for its chemical processes? We have A, calcium, sodium, chlorine, and iron. We have B, carbon, hydrogen, oxygen, and nitrogen. We have C, potassium, magnesium, phosphorus, and sulfur. We have D, zinc, iodine, copper, and manganese. Now these are all of these trace minerals are very important for chemical processes in our body, but most important, the primary ones are carbon, hydrogen, oxygen, and nitrogen. We talked about that ad nauseum. 96% of the body's mass is made out of those 4 elements right there. Okay? They're essential for forming proteins, carbohydrates, lipids, and nucleic acid. The trace elements are important, but not nearly. Only 4% of our body's mass. The pH of human blood is tightly regulated to stay within a narrow range to support life. Which of the following values best represents the normal pH range of blood? So remember what we were talking about? The normal pH range is right in the middle toward neutral. Like which of these numbers is closest to neutral, right? 6.8 to 7 is pretty close to neutral, but remember it was like slightly higher toward bases, which was 7.35 to 7.45. This would be like lemon juice or vinegar, and that would be like diluted lemon juice, and this would be like soap. So yeah. Okay, even small deviations outside of this 7.35 to 7.45 range can disrupt enzyme activity, oxygen transport, and overall cellular function. Carbohydrates play a vital role in human physiology. Which of the following best describes their primary function in the body? Okay, carbohydrates. What is the primary function of carbohydrates? A, building hormones and regulating metabolism. B, storing genetic information and directing protein synthesis. C, forming structural components of cell membranes and insulation. Or D, providing a quick and main source of energy for cells. Carbohydrates, I know, is a wonderful source of energy. It's sugar and all that. So building hormones and regulating metabolism, that would be like fat or like the endocrine system regulates metabolism, but so like lipids and fats, right, in the endocrine system. Storing genetic information and directing protein synthesis, that would be DNA, right? So that would be nucleic acids. And then forming structural components of cell membranes and insulation would be lipids for sure. Okay, so carbohydrates are the body's most readily available source of energy. So A refers to hormones, B is nucleic acids, and D describes lipids or fats. Proteins are essential macromolecules that serve structural, enzymatic, and regulatory roles in the body. Which elements are always present in proteins? Now look at these answers we've got. Carbon, carbon, carbon. Hydrogen, hydrogen. Oxygen, oxygen. And then here's where things differ, right? Now we know, because we just talked about 96% of the body's mass is these four things, okay? So we already know this one. So that was easy. Okay. So sometimes sulfur in some amino acids like cysteine, but mostly it's these guys, right? Phosphorus is characteristic of nucleic acids, not something you need to know for the MBLEx. And calcium is primarily used in bones and the nervous system signaling, especially important for us in muscle contractions. We're going to need to know that, but they're not a primary part of, calcium is not a primary part of amino acids or proteins. And that's that. If this video was great, you're watching on YouTube, this video was great and it did everything you needed it to do. Make sure and catch more videos. Give this video a thumbs up and subscribe so you can catch the next videos that are going to be coming up in the Anatomy and Physiology sequence. If you are watching this video on the... I just got something on my phone. If you're watching this video on the course, make sure and download your PDF of the slideshow so that you have it for reference. And also, if you're watching this on YouTube, make sure and get your download of the PDF slideshow that I'll have a link for in the description. And with that, I'm going to get going, and I will see you guys in the next video. That is going to be all about cellular structure and function. See you there. Toodaloo.